So next we want to welcome Dr. Paul Rodrigues. He's the Chief AI Officer for Microsoft's National Security Group. With a background in computational linguistics and leadership roles at Accenture and two University of Maryland's federally affiliated research centers, his work brings critical insight into how natural language processing and artificial intelligence can either safeguard or undermine civic agency. He's a key expert in discussions on data manipulation, data sovereignty, and the future of trustworthy information ecosystems. Let's welcome Dr. Paul Rodrigues.
Okay, thank you very much for having me today. Today I wanted to talk about large language models and what kind of bad things can happen at each of the layers and what companies like Microsoft are doing to help mitigate those problems. Before I get started, I wanted to kind of back up and mention that we could be talking about these large language models and what they could be done in the hands of a bad actor, or what we could talk about these large language models and what a bad actor could do to help train them. But there are also good actors that are positively motivated, that are creating algorithms that could do things that are misaligned to the end user. And that is what I'm most interested in for this talk here today. I've been supporting the federal government with natural language processing for around 15 years. I worked at the Center for Advanced Study of Language and the Applied Research Laboratory for Intelligence and Security, two DoD UARCs at the University of Maryland. After supporting the DoD at University of Maryland, I moved over to Accenture and supported primarily civilian agencies with natural language processing, which was extremely interesting. I'm currently working on a book on AI and national security for Wiley, and I started at Microsoft last summer, where I am the Chief AI Officer for the National Security Group. As Professor Honey mentioned, natural language AI and natural language processing go back to the 1950s and 1960s. And with that long history, there's been these boom periods and AI winters in which the funding goes down, the innovation goes down, but gradually over time, the productivity, the number of researchers, the number of papers per researcher have gone up. In 2018, a paper was released by Google called BERT, and it was a system that was extremely powerful. It was able to beat a number of different natural language processing tasks with one system, and it was very flexible. You were able to fine-tune it for a number of different problems very easily. And then ChatGPT in 2023. In between the two, between 2018 and 2023, the number of research papers in natural language processing doubled. The number of venues that hosted natural language processing research doubled. And this innovation happened very quickly. Around 2016, 2017, I was able to keep up with all the research papers in natural language processing. It was hard work, but I was able to do it by the end of the week. Around 2018, 2019, it became really impossible because there were papers published everywhere, and there was just an extremely high quantity. But with the number of research papers that are released annually, we have a lot of great innovation that comes out. Finding the right things takes some time, but they emerge, and we can work with them. With the research papers, we have a large amount of models that have grown over the past couple of years. This is a screen capture from Hugging Face and their model repository, and there was 1.8 million yesterday. And this is just one site and one model repository. There are several. This is the largest and one of the most easy to access. And in this 1.8 million, you have foundation models that are designed to be flexible and serve as a foundation of other applications. And you have highly specialized fine-tuned models that might do one thing and do it really well. And you kind of have to find those. And you know, some might be well documented and some might be less documented. Some might be produced by well-known researchers. Some might be just uploaded and you have no idea who it is that created it. But this is a great thing. Having this quantity is having a choice. But with the speed of the research and speed of the model development, we have this new issue in natural language processing in which as models are released, it takes some time to really understand how they work. And for a couple of years after BERT came out, there were papers like this one, and I really like this one, that dove in and analyzed what the different layers do, and tried to explain how this large system worked on the inside. And I think that this is certainly an important thing to do. I think in generations past, we would have waited to really understand how a system worked before we put it out. But I think this is kind of a danger about the current time. We're releasing the technology industry and developers and AI researchers are releasing models before we fully understand. And the model itself is a small unit of an AI application. And during this talk, we're going to go through each of these layers and talk about what kind of things can be done either maliciously or unintentionally that could harm the user. But I want to start off mentioning that the model is the core. I usually describe it as an onion or the rings of a tree. The model is the core, and there are layers around it. The model is the most expensive part, and as you go out, it becomes cheaper to develop. But the model is what requires a large amount of compute training and a large amount of training time, and a large amount of data. And so first I want to talk about AI alignment and what somebody could do with that. This is a step within when you're training the model to provide some rules and guidelines and to the model. It tries to teach the model to act in a well-behaved way, and that is such as providing truthful answers, making sure that the system is nice, but not totally trying to give the user what they want. You want to train the model to not be deceptive, and you want to guide the model towards which actions and which tasks that you want the model to do. And this is done through a test called reinforcement learning with human feedback, and they use annotators to provide choices, to record preferences from users. And this is an example from InstructGPT, which was the predecessor from OpenAI of ChatGPT. So you have long documentation, and the users are asked to, given some choices and asked to choose which one they like better. And during this step, and then this annotation is used to train a reward model, which guides the large language model during training. And alignment contains the human instructions, human preferences, and human values. And you can imagine that these might be different depending on what organizations train the model, right? The different organizations are creating their own annotation guides and hiring their own annotators from different pools of annotators. They might be employees, they might be external contractors, they might be subject matter experts, they might be linguists, they might be there's a large variety of people that may be contributing towards this annotation. And depending on how specific the annotation guide is, you are encapsulating the instructions and the values and the ethics from either the organization or from the pool of annotators. And so it's one of the things I mentioned earlier was we're at 1.8 million models, and this is a great thing because you have lots of choices from which model to pick. We know in advance that the models are going to have be trained on different data, be trained from different annotators, so they're going to have different facts and they're going to have different ethics. To limit that as a technology provider like Microsoft or Amazon would be limiting those choices from populations of people that may have certain preferences for information and certain preferences for values. One of what you don't want to have is hidden ethics or hidden values within a system. You want them to be easy to find so that you understand and can gauge the different systems and understand what the strengths and weaknesses of them are. And this is actually the hardest part of that onion because it's really difficult to look into these systems and inspect and understand how they would act with a given prompt and analyze the output. And one of the companies that has been working the most on and publishing it recently publicly has been Anthropic. This is a fairly recent paper that is looking at hidden objectives. So they trained a large language model that would act had a secret, and they recruited 4 different teams to try to identify what that secret is. The secret was that the system was going to answer very nicely and give the user whatever they want, even if the user is wrong. And the 4 teams used 8 different methods, and it was a combined approach of like interactively questioning the agent, trying to identify that secret versus inspecting the layers. And several of the teams were successful, but it was a very manual and intensive analysis. And that's where the state of the art is at the core of this onion. If you want to inspect to understand what a hidden motivation is at the core, it's going to be manual effort and interrogating the model. While Hugging Face has 1.8 million models, Microsoft Azure is currently hosting 11,000. That's up from, I think, 1,000 2 months ago. And so Microsoft is trying to provide many models as options, and that's going to be partially, understanding what your computational infrastructure is, understanding what your latency needs are, but also what facts and what values that you want to use in your system. As we step out of the model layer and look at the next level up, the safety system, these are much easier things to solve for. You may have heard of AI guardrails that are essentially the last-ditch effort to stop a system from producing harmful content for a user. And so many of the hosting providers have built-in guardrail systems, and these are Microsoft's. So these are things like identifying violence, sexual content, self-harm, protected and copyrighted content, and these are turned on by default. But this might not be the best defaults for a particular use case. If you are, for example, in law enforcement, you might want to turn these off. And so these are configurable. They're always on when you start, but if you are configuring a system for a different purpose, they can be turned off. Stepping out one additional level, we have grounding. And grounding is the ability to provide your own facts to the model. Now, if the model is completely, the model was designed to respond to particular inputs in such a way that it would refuse to answer, then no amount of grounding can fix that. And some recent models have been released that do that. They monitor for particular topics and shut down. But in other cases, you have a large language model, you can support it with additional data sets. And one of the methods that you may have heard about is Retrieval Augmented Generation. And this is a way to do this within with a number of different data sources. And the different data sources require kind of a different level of integration. You might have flat databases, you might have graph databases. Azure provides the ability to provide your own data set. But it also has the ability to detect from the responses that are provided from the system how well the system utilized that information that was in that data set. So you can set a threshold saying that if the facts weren't completely from my data set, don't display the fact. One of the open source systems we released last year around this time, GraphRAG, it was extremely popular. Lots of people are using it. It allows you to provide a graph of knowledge to your large language model to improve the grounding. One of the groups at Microsoft that's tasked with investigating the large language models before we put them up is the Microsoft AI Red Team. Red Team is a term borrowed from defense work that asks a team of multidisciplinary team members to put themselves in the mind of an adversary and with the tools of the adversary and thought processes of an adversary and see what you could do. And so not all of the models that we've put up utilize this, but anything that we've wrapped in an application. And a couple months ago, they put out, so they've been together since 2018, and a couple months back, they released a white paper that's around 50 pages that describe the lessons learned from their operations. And they really recommend the analysis of these systems to be performed holistically. So while they have a package of the AI application with all the levels, the model, the safety, the meta-prompted grounding, and the user experience, they're really analyzing the complete and total application. And they use a combination of automatic methods as well as manual methods because they've noticed that while you can decompose a large neural network and hack a system that way, these systems are designed to be interacted with via language, and there are lots of things that you could do via language itself. And so they are sitting there questioning the model, interacting with it, and seeing what they could do to jailbreak it and do other nefarious things. And one of the tools that we released is called Pirate, which helps automate the automated tasks by running large quantities of queries through the system. So in summary, the AI applications are really this multi-layered suite of tools. The model at the center is one of the most difficult to inspect and to understand, and the state of the art is currently questioning it and making sure that it's behaving well. But you also have the ability to inspect it computationally. As you move out from the layers, it becomes more feasible. In fact, it's now point and click in applications like Microsoft Windows and Office 365. You can easily create a custom RAG solution, a chatbot that answers off of your data set with your grounding rules in about 10 minutes of point and click. But understanding what that core model does is still a little bit obscure. Yeah, I think that's all I have for today.
Time for 2 or 3 questions.
Hi, thank you for delivering this talk. One question I had, so as components of testing and evaluation processes become automated, there are a lot of trade-offs despite efficiency gains, and one of those could possibly be recursive effects that negatively affect the model in terms of possible misalignment. Do you have any ideas for solvency in this area, or is it just a trade-off we're going to have to make as we automate processes like red teaming, reward modeling, and annotation?
Can you explain what you mean by recursive effects?
Just like models evaluating themselves could lead to possible recursion, especially if the evaluator models are misaligned in some way.
Yeah. So there are, again, this is an area that researchers are actively working on and trying to identify methods. Many of you may know that one of the methods for training a large language model is this idea of self-training, in which a model helps provide the answers and then is evaluated based with a reward or not. And so you do have this idea of a model feeding itself answers to help train the model. And then she was asking about whether external models can also be, I think it's really interesting. The recommendations right now are to keep a human in the loop, an interdisciplinary team that can help design the challenges. The AI red team isn't necessarily using the same prompts to test each of the models. They're really digging in and utilizing their backgrounds in natural language processing, in linguistics, in psychology, and cybersecurity to quiz each model individually. And that is, if you are interested in this topic, I really recommend looking at the papers from Anthropic that are looking at alignment and secret holding, and training a system to hold secrets and techniques that you could use to exfiltrate those secrets from the model. I think it's really interesting research.
My question is this: as you evaluate hidden objectives, how do you include a variety of demographics, especially those who may not necessarily have previous input into technology? And there's a large segment of the world where this is true. How do you include those people who ultimately become the targets and recipients of the technology, but have had no real input into the way that the technology is being?
So annotation teams that are helping to align these systems are recruited from all around the world, and different companies are making different levels of efforts to ensure that diversity in the data sets. I think that you know, that's a really, I think it's a easier problem to solve than the question of designing the annotation guide in a way that respects multiple values and multiple there's just a way that with the annotation guide itself, you can direct a team of annotators, no matter where they are in the world, what their own cultural values are, to elect options in particular ways that will sway the end result of the large language model for all end users. A simple example I was thinking of is the idea of, for example, if you have a large language model that is being created by a religious group, and that religious group might have different options in the different examples in the large language model that are looking for human preferences, and they say in the annotation guide, opt for a monotheistic example over a polytheistic example anytime that those examples come up. That is training a system with a religious bias that would then make all decisions based on that annotation, no matter how they're being used, whether it's in a conversational AI system or being leveraged to generate a company's quarterly report. And so that ability to encode the values up front requires a careful approach to the annotation guide, as well as a diverse population of annotators.
Thank you for the talk. You know, seeing this figure with the different layers, right? It can make it feel like security, privacy, ethics are an afterthought, right? Like you're putting patches on top of something, right? Why not embedding those things within the model?
One of the model itself, the models themselves are private. The way the system is trained, it creates a binary application that is generally not updated because it's very expensive to update it itself. What you have to worry about is this entirety of the user experience, the entire application. Because you may have a well-trained model with proper guardrails that's sitting in and being hosted by somebody with bad intent, and they could be recording everything that you're doing. I think that this idea of tacking on the safety features and the grounding features is probably I wouldn't say an afterthought, but it controls a wild beast, right? That can do anything and be aligned to any particular direction, right? Any particular values. A bad actor that is intentionally trying to be bad can train their own model that would stop at nothing to do, you know, to take down the New York Stock Exchange, right? You could, if you have the expertise, the AI expertise, you could build a model that will go do that and do nothing else. The issue is that when you're taking that into an environment in which you're trying to share a model, like with Azure would be doing, you want to constrain that system in addition to understand what it would do, right? If obviously we want to put something like that up for everybody. But this is a common approach used in cybersecurity scenarios in which you're building virtual machines on top, right? You're trying to encapsulate the system and allow it to do only the things that you want it to do, assuming it's the worst possible system.